Hello everyone. In this video tutorial we are going to learn consistency and solution of linear equations in Scilab. In this video lecture, first we will see introduction. In introduction, what is a rank and how to find rank in Scilab. In second part, we are going to see condition of consistency of linear equations, and third one, to check consistency of linear equations in Scilab, and if equations are consistent, how to find the solution. Let us see what is the definition of rank. Let A be any non-zero matrix, then the integer R is called rank of the matrix A E. There exists at least one minor of order R which is not equal to 0, and every minor of order greater than R is 0. Then R is called rank of the matrix. In Scilab, rank can be obtained by using inbuilt function called as a rank. For example, if A is any non-zero matrix, then rank can be obtained by using the command rank of A. For example, go to the console, enter A be any matrix of order 4 by 5. Now the elements are your choice, and use the command rank of A and observe the solution. Pause the video and try to find rank of any matrix of order 4 by 5. Thank you. Next, consider a system of m linear equations in n unknowns which can be represented in this form, and this system can be represented in the matrix form Ax equal to B, where A is a coefficient matrix, X is the matrix of unknown, and B is a constant matrix. So from this, next we define an augmented matrix AB, which can be obtained from the coefficient matrix by attaching one more column to that matrix, and that column is a constant matrix. Suppose we are given a system of equation in the form Ax equal to B. Then this system is consistent if and only if rank of A and rank of augmented matrix AB is equal. Suppose rank of A and rank of AB is equal, and that value is R. Further, if R is equal to number of unknowns, then the system has a unique solution. If R is less than number of unknowns, then the system has infinite solution. Now instead of Ax equal to B, suppose we have a system of homogeneous equation in the form Ax equal to 0, then this system is always consistent. That means in Ax equal to 0, rank of A and rank of A are always same. Consider an algorithm to write a Scilab code to check the consistency and if possible to find the solution. So after start, our first step is to input the matrix A. So this matrix we can consider from the users. Second step, calculate rank of A, and that will be stored in the variable R, and next variable is a S, that is the order of the matrix. So while writing code, I am using S as a minimum of order of the matrix. For example, if A is a matrix of order m by n, then S will take the value of minimum of m and n, because the greatest possible rank of R is minimum of m and S. Say matrix B, and from that obtain an augmented matrix AB, and it can be denoted by a new matrix, suppose C, and let R1 is a rank of a augmented matrix AB. The first condition we have to check, if R is not equal to R1, this sign is used for the not equal. If R is not equal to R1, if the condition is true, display the system is inconsistent and straight away end the program. Suppose the condition is false. So once again you have to check the logical statement. That means two conditions are there, this and this together. If R is equal to R1 and S is equal to R, then that condition is true. Then display the message that the system is consistent with unique solution. And if you want to find a solution, here you can obtain a unique solution of the system and end the program. Suppose the condition is false, either any one or both are false, then in this way you have to display the message that system is a consistent with infinite solution, and one of the solution you can obtain here and end the program. So let us shift to a script file where I already written a code to check the consistency of the equations. So one by one I will explain. So first two lines are general, CLC and clear. CLC is to clear the console screen. Clear means clear all the earlier variables. So first enter an input matrix A. A is a coefficient matrix and let R is rank of A. Now the next step, input a matrix B, that is called as a constant matrix, and from the matrix A and B, here we are obtaining a new matrix which is called as augmented matrix, and that matrix we call as a C. Now we display that matrix C to the user. Now the next, suppose R1 is rank of C, and already I was explained S is a minimum of size of A. Size of A is nothing but the order of the matrix. Now the first condition we have to check, if R is not equal to R1, then display the equations are inconsistent. If the condition is false, once again check the logical statement, and if R is equal to R1 and S is equal to R, then display the system has unique solution. And if the condition is false, then the system has infinite solution. So here I have to check the condition that the equations are consistent with unique solution. Unique solution, and the equations are consistent with infinite solutions. Infinite solutions. Let us check this is a solution, and first we will end a first if loop and then second if loop. So run the program, save and execute, go to the console. Suppose we are having one system which as 1 2 minus 1, that is the first row, comma 3 minus 1 2 semicolon 2 minus 2 3, next row 1 minus 1 1, this is a coefficient matrix A. Next matrix B, that is a constant matrix, 3 1 2 and minus 1. So after enter, we will get a coefficient matrix, augmented matrix with the solution type. Now in this case, the augmented matrix C is, and the equations are consistent with the unique solution. Now once again I will shift to the script file. Suppose further, after checking the condition, I want to display the solution also. Then here, now the first case, if the condition is false, if R is not equal to R1, then there is no solution. If the condition, second condition is true, then the infinite solution. I will calculate X is equal to A by B, and I will display this X. I will display this X. So once again run the program, save and execute, come to the console. So once again I will enter the same matrices. Suppose the coefficient matrix is same, the matrix B is the same, the equations are consistent with unique solution, and the solution is minus 1 4 4. You can verify any one equation, minus 1 plus 8 minus 4 3. In the same manner, suppose if the system has infinite solution, then also you can find one of the possible solution by using the same command. And once again I will use display of X. Once again run the program. In this case I will use a infinite case. Go to the console. Suppose coefficient matrix is 1 2 0 1 semicolon, second row 1 minus 2 2 3 2 0, this is a coefficient matrix. The constant matrix is 4 7 1. Let us check the solution. The equations are consistent with unique solutions. So likewise you can check Any example? Shift to the presentation mode. So further you can verify these three examples were given in the presentation. You can check the consistency of these equations. Thank you.